So in the last section of the last video, we were talking about finding the height of a tower, but it's sitting inside a locked courtyard, which you do not have access to. And you might be wondering why I keep bringing up these scenarios and locking more and more things. First, I lock the door to the tower, then I lock the gate to the courtyard. Why am I doing these things? Just consider this example. You want to measure the height of a could be anything, could be a hill, it could be a tent. Imagine that you want to measure the height of this hill. You can't just stand at a point which is at some distance away and measure the angle and measure the distance to the foot of the hill. And when I say foot of the hill, I'm referring to the point directly below the highest point on the hill. You cannot do that because you can't go through the solid rock. So the tower in the courtyard is just an example that models these limitations. That's why we are talking about this. So we have a tower with an unknown height that we are trying to find, and you do not have access to the point directly below the top of the tower. So how do you go about doing this? Here is one way to do this. Find a point from where the angle of elevation is 60 degree. And find another point where the angle of elevation is 30 degree. And these 2 points and the foot of the tower should be in the same line. This is something that you can do even if you are not able to enter the courtyard. You can just find this point first and then go further up, away from the tower, and you could maybe put a small flag here, and when you're standing there, the flag should be directly in front of the whatever you can see of the tower. That is all, right? So 60 degree elevation, 30 degree elevation, you found 2 points. Now you can measure, you can find the height of the tower by making an indirect horizontal measurement here between the 2 points. You don't need access to the inside of the courtyard. So let's see how that works. Just call this distance as x. So then because you have a 60 here, the height will be root 3x. Notice that in that triangle, you can name these triangles if you want: A, B, C, D. In triangle ABC, if you look at the 60, the opposite side is the height AB, and the adjacent side is the distance from the point C where you're standing and the foot of the tower. But you don't have access to that. So let that distance be x. I don't know what x is, but I can say that the height would then be root 3x. Now you do this again with the triangle ABD. Tan 30. So first you use tan 60 in triangle ABC. Now you are using tan 30 from triangle ABD. Tan 60 was AB by BC, and your tan 30 is AB by BD. Now you know the tan 30 is 1 by root 3. Here it is root 3. This is what gave you AB is equal to root 3x. Now using this, you can say that BD is AB root 3. AB is already root 3x, so you'll get BD is equal to 3x. So then I say that this thing right here is 3x. Now what is the length of CD? CD is just BD minus BC, so it's going to be 2x, and 2x is what I'm measuring, right? My measurement is 2x. If you take your measurement and divide it by 2 and multiply by root 3, you will get root 3x, which is the height of the tower. So my height is the horizontal measurement into root 3 by 2. I have indirectly calculated the height of the tower by using a horizontal measurement, and that measurement did not even require that I have access to the point perpendicularly below the points whose height I'm trying to find. So that is how you would do this for a tower in a courtyard, which is just a simplified example for something like find the height of a tent, height of a hill, etc. Let's look at an example question. Ashwin was walking towards a building at a constant speed. At a certain point, he noticed that the angle of elevation of the top of the building was 30 degrees. 20 minutes later, the angle of elevation was 60 degrees. How much more time in minutes will it take to reach the foot of the building? So we have a building with some height, and we have the horizontal ground on which this person is walking. At a certain point of time, he saw that the angle was 30. Later, the angle was 60. 30 degree, 60 degree. I'll call this A, B, C, D. When he was at B, it was 30 degree. 20 minutes later, he had reached C, and the elevation was 60 degree. How much more time will it take to reach D? So all you gotta do is take this as X, and then AD will be, so what you have in triangle ACD, tan 60 is root 3 is opposite by adjacent. This would give you AD is equal to X root 3. Then you take triangle ABD, where you have a tan 30, which is 1 by root 3, which is AD by BD. Cross multiply and you'll get BD as AD root 3. AD is already X root 3, so you'll get BD is equal to 3X. So this is 3X. So then clearly the distance he has already walked is 2X, and it is double the distance that he needs to walk further. So the distance left is half of the distance he has already walked, and the time that will be taken will also be half because he's going at a constant speed. So your required answer is 1 by 2 of the 20 minutes that he has already walked. You will get 10 minutes.